So find the z-score for the given value of x, mu, and sigma, and interpret. So in order to do this, we need this formula. I'm just going to copy it down here. Z is equal to x minus mu over sigma. So in part A, these values could mean anything. Like x could be ages. They could all be in ages. They could all be income in thousands. Whatever. It doesn't matter. So the normal problem value is 42. The z will tell us the standard normal problem. And all you do is you plug it in. So z will equal x, 42, minus mu, 22, over sigma, 10. What is 42 minus 22 over 10? 2. How nice. It's a whole number. Before we do part B, let's talk about what's happening. So if we were to draw a number line like we did for the previous problem, and I was going to draw my normal curve, what number would go in the center? .22. The mean always goes in the center. And then the standard deviation dictates how far apart the tick marks are. So after 22, I'd have 32, 42, 52. So remember, we go 3 up, then we go 3 down. Oh, I hope these aren't ages or incomes. That's okay. Let's draw the standard normal. In the standard normal, 0 is the mean, and the standard deviation is 1. So this would be 1, 2, 3, negative 1, negative 2, negative 3. So in normal talk, when we had our x's, we said that 42 is 2 standard deviations above the mean. Well, 42 is an x. 2 is a mu. I'm sorry, not a mu, a z. Oh, and I have to erase all that. That's okay. Z. Oh, that's in red. That's okay. Well, notice it lines up perfectly. The number 42 as an x relates to the number 2 as a z. And they both mean that we're talking about a number 2 standard deviations above the mean. If it was negative 2, it would be 2 standard deviations below the mean. Very good. So that's all we're doing is we're standardizing the problem. So instead of caring about the 42, the 22, and the 10, we're now talking about 0, 1, and 2. Deviations above the mean? Oh, the top one is a normal distribution. The blue one is a standard normal distribution. Let's do part B now. So part B. Let's find the z-score first. So how do I fill this in? Uh-huh. Good. What is 50 minus 60 divided by 4, rounding to 2 decimal places as necessary? What'd you get, negative? So be careful. You have to round to 2 decimal places. Always, always, always. So let's do the same thing. We'll draw the same number line. For part B, what number goes in the center? 60. And our standard deviation is 4, so we're going to go up and down 4. So 64, 68, 72. 56, 52, 48. And again, these are x values. Well, notice the number 50, the x value 50, on our number line would be about right here. But unlike in part A, it's not a whole number deviation away from our mean. It's a decimal deviation. Well, this is where the z value, this is what the z value tells us. So drawing our number line, just like before, 0 in the center, standard deviation of 1. Well, here's negative 2.5. So what this is saying is 50 is 2.5 deviations below the mean. So the number 50 as an x relates to negative 2.5 as a z value. You should have an idea of the signs for your z values based on your x's and your z's. If your x is bigger than your mean, then your z value should be what? Positive. If the x is smaller than the mean, your z value should be negative. So we would already know before we did it if it's going to be above or below. So in part A, we would not need any of this stuff because we could approximate it with the 68, 95, 99.7 because we got a whole number deviation. But in part B, we did not. We would have to convert it to a z-score and then use this table that I'm going to show you. And with the table, we figure out the probability of, in this case, it could be picking someone who's less than 50 years old.